Okay, so we have started cholesterol steroids. So as in our previous lecture, we have seen the how to do the nomenclature, how to do the numbering for the steroid nucleus and all. Okay, so basic part we have finished. Now we will go for introduction as well as for method of mechanism of cholesterol. Okay, biosynthesis of cholesterol. So as we have seen the structure of cholesterol here, I have given the structure of cholesterol. It's a part of hydroxyl steroid. Okay, so cholesterol. So at the end, OL represents it's a alcohol. So cholesterol, alcohol containing steroid molecule having carbon-carbon double bond. Okay. So numbering we have seen in our previous slides or lectures. So how to do the numbering. So all four molecules or four aliphatic aliphatic cyclic rings. Okay, they have joined ABCD, four different rings, three six-member ring and one five-member ring. They have joined. They have fused with each other. They are fused with each other, and numbering is very simple. So basically, what they have done, the numbering plainly for the rings carbon atom first. Okay, so as you can see over here, the molecule A, cyclohexane ring A, B, C, and cyclopentane ring is D. So plain numbering is 1, 2, 3, 4, 5, 6. So this 10 membered ring, that means 10 carbon atoms they have finished over here. Now they jump for the 11th carbon atom or for the of the 6 C molecule C ring. Okay, so 11 carbon atom is they have label in the C ring. 11, 12, 13, 14. Okay, 11th 11, 12, 13, 14 continued in 5-member ring 15, 16, 17. Okay, so 17 molecular ring is common for the steroids. Okay, steroids, this is the basic structure, basic moiety of the steroid classification, under which comes under the steroid classification. So 17 membered rings, four rings, three 6-membered ring and one 5-membered ring. This is the basic structure for steroidal chemistry. Okay, and remaining the attachments or the alkyl groups which is present on the steroid, those remaining molecules or remaining alkyl attachments you can attach, and you can start numbering from that one only. Okay, so 17 number, then they have given number 18, which 18 number for the methyl group which is present at the carbon number 13, then 19 methyl group, they have indicated with the carbon atom, the methyl group which is present at the carbon atom 10. Okay, so this is this type of 19 and 20 they have given here, 21, 22, 23, 24, 25, 26 and 27. Okay, so numbering is also quite easy in case of steroids. Now, as we have three cyclohexane rings and one cyclopentane ring, so definitely there should be chair conformation, that steroid molecules present in the chair conformation. So we have seen the stereochemistry of decalins, that means two 6-member rings when they are fused together. Decalin, we do call it decalin. So we have seen trans decalin and cis decalin. So which one is more stable? That one also we have seen, and why those are more stable. So because we have to pay attention at the carbon atom which is present at the bridgehead carbon atom. Okay, so this carbon atom, the hydrogen atom which is present at the bridgehead carbon atom. So these hydrogen atoms, stereochemistry of these two hydrogen atoms, they decide the stereochemistry of your steroidal molecules. Okay, so the two hydrogen atoms, one is present above the plane, one is present below the plane. Okay, so that's why this is transdecalin. So in cis decalin, that means in cis means cis means these two. Okay, this ring is cis to this ring. Okay, so fusion is there. These two fused 6-membered rings, they are cis to each other, is nothing but in this molecule, in this ring also, these two bonds which are fused together at the next bond, both are equatorial. Okay, this bond is also equatorial, this bond is also equatorial. Okay, so these are the okay, so this is below the plane, this one is pointing above the plane. But the if we will pay attention at the hydrogen atoms, two hydrogen atoms present at the bridgehead carbon atom, the position of these two hydrogen atoms both are present above the plane, because another six membered ring, the orientation of this six membered ring is one bond is equatorial, one is axial. Okay, so here if you translate, you can see both are, this one is also equatorial, this one is also equatorial, this is also equatorial, this is also equatorial. So all four carbon-carbon single bonds, they are equatorial to each other in transdecadene. That's why two hydrogen atoms at bridgehead carbon atom, they becomes anti to each other, or they are pointing opposite to each other. Okay, but here as one of the carbon-carbon single bond, it becomes axial. That's why the orientation of this hydrogen is changed from axial to equatorial. Okay, so one carbon-carbon single bond now here axial to this hydrogen atom. So okay, here hydrogen atom is axial, but here carbon-carbon single bond is axial. So these two are in opposite direction, carbon-carbon single bond and carbon-hydrogen bond. Now carbon-hydrogen, another carbon-hydrogen bond, that one is equatorial. That means this hydrogen and this hydrogen, they both are present above the plane. That's why this is cis decadene. Okay, so this is the stereochemistry regarding our steroidal molecule. The same things we are going to represent in the in any kind of steroid. So let's say same stereochemistry. So here you can pay attention, ring flip in both rings. Okay, so how the rings are there flipping, and then how you can write down the structure, rotating by 60 degrees centigrade, and how it will appear. Okay, so like that, so many notations are there. Okay, so now in which how many different types of stereochemical, how these four molecules, how this four membered ring, how these four rings, they do present in different ways, and how many of these, how to write all these things. So I have given here, and here is the possibility of all four rings, three six membered ring and one five membered ring, possibility of all these rings in which orientation they do present. Okay, so here you can see AB, here both A and B molecule, they are cis to each other, here also cis to each other. Okay, due to unsaturation they cannot be cis, they cannot be trans to each other. If unsaturation comes at the bridgehead position, then it changes whole stereochemistry. There is no stereochemistry applicable over here at the bridgehead carbon carbon double bond is present. Okay, but here you can say the stereochemistry of A and B ring, C and D ring. Okay, so this is the thing. So unsaturation at fourth carbon atom, so we have to write down delta 4. Unsaturation at the fifth carbon atom, so we have to write down delta 5. Now two double bonds are present in this structure at fifth position, at seventh position. So we have to indicate delta fifth and delta seventh unsaturation. Okay, so these are the common rules for the numbering of the steroidal nucleus. Now we will see one by one how is the cholesterol, how we can synthesize.